Okay, as I told you guys yesterday, for today, we will focus on discussing some problem on the trust, especially if we have to use the section method. Okay, about the section method, anyone here want to ask question first? Then after that, I will discuss some problem example before discussing about the final theory about the trust system. Okay, anyone here? Anyone want to ask question? Yes, Mudafi. Do you have any question, Mudafi?
No, sir.
Nope. Adila or Nuki, do you have any question?
No, sir.
No. Okay.
No, sir.
Okay, but I believe in order for you guys to have a better understanding on the trust system, I believe it is better for us to have a more problem example, right? Correct or not, Nuki? Do you need more? Yeah. Okay. Asyap, yes. Okay. So for today, I think I will discuss several problem example for you to get used to it. Okay. And then after that, I will discuss at the end of maybe in the last 45 minutes, I will discuss about the last theory that you need to know about the trust system. Okay.
I'm sorry.
Yes.
Can you just jumpstart memory for the section theory?
You mean you want me to re-explain about that, right?
Yes, but I don't really get it.
So you still haven't get it yet? You still haven't got it yet? The theory behind the section method?
Yes, I'm still confused after we divided by two.
Okay, so it's like this. Basically, section method, it will be very useful if we have to find out only force which is happening at certain member only. For example, the problem that we discussed yesterday, okay, we only need to find the force which happening at member BC, BE, and EF. But in this kind of problem, then we can simplify it. Not simplify it. We can use section method by doing the cutting here. Okay, the basic theory of the section method is when you cut a particular member, when you cut a particular member, that particular member will become external force for both system, the left system, the left free body diagram, and the right free body diagram. Okay, so basically after we cut, we will be able to have two free body diagram. Okay, the first free body diagram will be the right one, the one that we discussed yesterday. So all the members there will become internal force. Then we have 40 kilonewton external force, beside that, the member which is part of the cutted member, okay, will become external force as well. Something like this. This is FEF, and then this is FPE, and then this is FPC, something like that. It will become external force, but this is only our first free body diagram. Okay, the right free body diagram. The left free body diagram, we can draw it as well. Okay, we can draw it like this. Okay, remember that the cutted member, the cup member, will become our external force. So it's like this. FBC, then
FBE.
yeah, FBE, correct?
And
FEF.
Yeah, FEF.
But that's not all, because at point A there is a pin joint, yeah, and at point G there is a roller joint. So we have to add as well here
the reaction force.
Yeah, reaction force AX, AY, and
GY.
Actually, it's not GY, but GX.
Oh, GX.
Yeah, the direction is GX. Something like that. So the this is the results of the first free body diagram, the right free body diagram, and this is the results of the left free body diagram. But unfortunately for us, Ananda, this particular problem, we are only asked to find out BC, PE, and EF, right?
Yes.
Okay, just by solving the right free body diagram, it will be enough for us, correct or not?
Yes.
Because we have three unknowns there, and each free body diagram, we will have three equations, right? Based on the things that you learn in the equilibrium, right? So we can solve it using only the first free body diagram. Using sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Because it's not point equilibrium anymore. It's a one free body diagram, one whole free body diagram, and this equation is the equation that we will need to use, but for the first free body diagram. Actually, the second free body diagram, you can solve it using the same, not the same, but say another set of sigma fx equal to 0, sigma fy equal to 0, sigma moment equal to 0, because each free body diagram, every free body diagram will have one set of sigma fx, sigma fy, and sigma moment equal to 0. Correct?
Correct.
Yeah. But using the only the first free body diagram, okay, it's enough for us. So why we need to use the second one?
I'm sorry, sir. Why do we need to use the second one?
Just by using the first, by using the first free body diagram, it's enough for us, right?
Yes, it's enough.
So we do not need to use the second one.
Because the external force is on the first body diagram.
Yeah, so, external force that we need to find. Actually, there are several other external forces that we have here, AY, AX, and GX, right? But we don't have to find that. Those are not part of the external forces that we need to find. That's why save your energy and solve the things that you need to solve. You get it, Hasan?
I get it, sir. Thank you.
But sometimes, just solving one free body diagram is not enough. Sometimes it's like that. Sometimes you have to solve both free body diagram. It depends on the case. But if it's possible for you to just make solving one free body diagram is enough, then try to make the cut, because the cut here, where you have to cut, actually it depends on you, right?
Yes.
It depends on your creativity. So try your best to find a line, a cutting line, where just by using one free body diagram is enough. Try your best to do so. But sometimes it's unavoidable to use two free body diagrams.
Oh,
You get
I
it?
see.
This is for
I
everyone
see.
as well. So basically, that's our purpose. Whenever we want to solve we want to solve a certain member only. Try to make that member as external host by cutting that member. Okay, but sometimes, for example, it's like this: if the asked member is AB, BC, and BE, AB, BC, and BE, it will not be possible to solve it just by using one free body diagram. It's not enough to solve it just by using one cut. Like this, right? This one AB, BC, and BE. If those three are the one in question, it will not be enough for you to just using one cut only. There are several ways. You can use the same cut as before, solving for BC, BE, and FEF. Okay? Then after that, solving for joint B. Solving for joint B using joint method. So actually, everything depends on your creativity right now. I already give you guys two methods, two main methods. One is a join method. The second one is section method, and you can use it in conjunction. You can use it together. Okay, one to complete the other. You get it, Asa?
I get it, sir.
Yeah. So not necessarily one is better than the other, but you can use both to solve the problem in the problem that you need. Okay. Any other question about this? Azar,
Yes, sir.
yeah, do you have any question, Azar? That's did my explanation just now give more information to you?
Yeah, it actually gives a good review of yesterday's material. So.
And beside that, it's not necessary you have to just concentrate on one method. You can combine. Okay, you can combine several methods. Okay. Yes. Yes, Shabina. You want to ask question, Shabina?
Okay.
Hello, Shabina. Hello, Shabina. Do you have any question? Anyone else want to ask question?
Yeah.
I think jumping to the problem is
Okay, then.
maybe gonna ease our.
Is your what?
No, I mean better understanding because
Okay.
if only like the body diagram, sometimes I am confused. Like I'm sometimes, sir, I'm still confused. Like how to determine the compression and tension. Sometimes I'm still a little bit confused.
Okay. Oh yeah. I forgot about that. Actually, can you see the first free body diagram and the second free body diagram here? Right. In
Sir?
both free body diagram, right? In both free body diagram, I assume that FBC, FPE, FEF are in tension.
Yes.
Because that's my way to do it. I like it doing it that way Because in statics, we always say that under tension is a positive force, and under compression is negative force. That's what we normally do. Okay, that's why I always assume everything in tension. For example, like this: FBC is tension, FBE tension, FEFE tension. Why tension in this current case is going outside of the joint? Yeah, because when you talk about tension, right, it's actually what happening at that particular member. Actually, the member is getting pulled by the joint. But if we take a look at the joint, for example, this case, okay, the member is the one who pull joint. That's why it's going outside of the joint. So whenever we talk about tension, okay, whenever we talk about tension, it's always going outside of the joint. When you make the joint as your area of interest. For example, like this, when I draw the free body diagram, joint is part of the area of interest, but the member is not. Okay, the member becomes the external force. So when we take a look at certain joint, yes, it will be going outside of the particular joint. The same as this one. When we take a look at the second free body diagram, the left free body diagram, we have the same force, right? FBC, FBE, and FEF. Okay, if you look at the direction there, okay, maybe some of you will be a bit confused. Why it's going that way? Why it's going the opposite of the first free body diagram? It's mainly because it's under tension. When it's under tension, it's not going right or left, but it's always going further away from the joint. Okay? So we can see right here. I take a look at the joint. Joint is part of the area of interest. The member is not, because the member, the cut member now become external force. When I take a look at the free body diagram, which joint is part of the area of interest, the force is going out. The forces are going away. Okay, FBC is going away, FEF is going further away, and FBE is going further away as well. That's why the direction is like that.
So it can be like this, like in B joint it will be compression, and in C it will be tension. It can be like that, or
it can be like that. It can be like that based on our calculation later. But at first, like it or not, you have to assume whether it's under tension or compression. My suggestion for you: always assume everything as tension. Then later, when the value is negative, okay, then that particular member is under compression with this kind of force, with this magnitude of force, like that.
Okay. So if we assume FBC from the B joint is tension, but suddenly
the calculation result is negative,
so it will be compression.
Yeah. The actual thing that is happening is actually under compression.
Okay. I see, sir.
That's the easiest way to do it. Okay. Okay, but if you have easier way to do it, it's up to you guys. Okay. Now, let's start with the next problem example. Is in this particular thing, right? The one in question.
Sir, I have a question. Can you go back to the last slide?
Last slide, yes. Who's this?
Yeah.
Oh, Matthew, yes.
Yeah, so let's say BC is positive at the first free body diagram. Does that mean
positive is tension?
Okay, so it's to the left and the value is positive. So minus x. Let's say minus.
The direction is minus x, yeah. But for this one, we normally don't use minus x or plus x, Matthew, because.
Oh no, it's just. Yeah. I'm just trying to say that it's to the left.
Okay, to the left, yes. Then.
from the first body diagram, FBC is proven to go to the left. What happens if we look at from joint C? Will it still be to the left or to the right?
Okay.
Just the joint C. Yeah.
Just now, okay. From the first free body diagram, it's the value is positive. Okay, FBC, you mean?
It's the direction is to the left.
Okay, and it's based on your assumption or based on your calculation. So first, the sequence is like this. First, you have to assume like this. Then after that, you have to calculate. That's why I'm asking you. This is based on your assumption, the first step, or based on the second step, the calculation step.
Let's say I assume the direction will be to the left, and after calculating, the value is positive.
Okay, then.
And then if we look at joint C only, will FBC also go to the left, or?
If we take a look at joint C only, so you mean by using joint method, later you will get that FBC will be under tension.
Under tension, so.
And the value will be exactly the same as the value that you got from the first 5 free body diagram.
Under tension, so the direction will be to the left also.
If you take a look at the joint C, yes, it will be to the left.
Okay, so if we take a look at B, it will be go to the right.
Yes.
Okay, thank you, sir.
Okay. This one, right? FBC. Yeah, if you calculate, right? If you calculate the results here, yesterday, yes, FBC, the results of FBC, it will be. Okay. Oh no, this is not this one. This one, yes, yet to find. You have to solve for the trigonometry first in order to solve this one. So the angle is 2, 3, then 2, 3, yes. The trigonometry is quite tedious here, but it's still solvable. Okay, the angle for this one, right? The problem here is we have to solve for all the angles first before we calculating this. But anyway, I think I will just try with this one because this is new problem and you haven't tried yet. Okay, the previous one we have discussed it for quite a while, so I think we will try with this one. Okay, for this one, the one in question. Okay, the one in question is member CD. Okay, member CD. Member CD, member BF, and member GF. Okay, anyone here can help me the step-by-step to solve this particular problem. So you have to find out, actually it's not each member, okay, but only these three. Can you help me to find out the forces which is happening at these three members?
We cut the body.
Directly? Do you know all the external forces, Rizky?
Not yet, Pak.
Yeah. For this kind of problem, because it has a pulley there, right? The first thing that you have to solve is the external forces. So you have to create the free body diagram, and after that you have to solve for the external forces first. Then after that you solve it by using section method. Okay, you can see here, there is an external forces of L there. Okay, we can assume the L is equal to 100 Newton. Okay, L is equal to 100 Newton. Then, what are the forces which is happening at pin A? What are the forces which is happening at pin G and pin F? Those are the most important. Information before you can go further. Anyone here can help me to find out the forces which is happening at pin A, pin G, and pin F.
In A only tension, but 100 Newton.
Pin A only tension. You sure about that?
Oh, never mind.
Are you sure about that? Okay, in order for you to do so, the first thing that you have to do is to try to draw the free body diagram of the pulley. Risky. So don't be too fast and on assuming something risky. So it's like this way. This is the pulley, and you know that the pulley there is a 100 Newton going down like this. But remember, there is another tension force with the angle of 10 degrees here. Right? Okay, and then here we will have AY and EX. Correct or not, Rizky?
Yes, Pak.
Is this the free body diagram, Rizky? The free body diagram for
Free
this
body diagram at A. Yes.
at A. Okay, AX and AY later will become the forces which is happening at joint A. That's the thing that we have to do. You get it, Rizky?
Yes, Pak.
Okay, so from this particular free body diagram, then we can use this one. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Using sigma moment at A, what we will get is T will be equal to 100 Newton. Because sigma moment at A, what we will get is 100 Newton multiplied by R minus T multiplied by R is equal to 0. So this is what we will get there. Okay. Anyone having problem? Should be okay, right? Then after that, using sigma fx equal to 0, okay, what we will get is we have to list out all the x direction forces. The x direction forces that we have there is only ax and t. Okay, but t there we have to multiply t with cos 10 degrees. So in this case, what we will have is ax is equal to t cos 10 degrees, where t here is equal to 100 Newton. So 100 Newton cos 10 degrees. Okay, that's my ax. 100 Newton cos 10 degrees. Cos 10. Wait, cos okay, correct. Cos 10 degrees multiplied by 100. Hey. Wait, cos 10 multiplied by 100. 98.48. Correct me if I'm wrong, okay? That's our Ix. Then using sigma Fy equal to 0, what we will get will be, we have to list out all the y direction first. Then we have Ay, we have 100 Newton, but minus because it's going down. And then we have T as well, but it's minus because it's going down. T sin 10 degrees equal to 0. Then what we will get will be Ay is equal to 100 Newton plus 100 Newton sin 10 degrees. That's why Ay will be sin 10 degrees. Okay, 17.364 Newton. Those are your Ax, Ay, and T. You get it, guys? Azab, do you get it, Azab?
So we basically work with the pulley first, then
Yes.
we work with the truss.
Yes, of course. You have to force. You have to solve all the forces which is happening at the pulley. Then after that, you can solve for the truss.
And
Because
also,
we have to determine the external forces. Azab?
yes, yeah.
Yeah, that's the thing.
So by separating the pulley and the truss, it also counts as a suction method.
Sorry.
So by
Solving the
separating the truss and the pulley, it also counts as a section method.
no. This one, I just determining the external forces because
I see.
I haven't got any information about the external forces. That's why I need to determine the external forces.
I see.
Okay.
Okay.
That's only for pulley A. Okay. For pulley G, we haven't got it. We haven't got any information yet as well. Okay. At pulley G, we have, but we have is like this. Okay. Everything is 100 Newton, but 100 Newton, and nah, this one is the same as this one, so it's 100 Newton. T equal to 100 Newton. T1, okay. T1 equal to 100 Newtons. Everything is T1. Now this one is T2, and beside that we have GX and GY, right?
Enggak,
Cuma gini doang.
itu cutting
Yes,
mat
okay.
namanya. No, sir, I accidentally unmute myself. Sorry.
Okay, no problem. Okay, so for this one we can solve the same thing using sigma using sigma moment equal to 0. Okay, what we will get will be T2 will be equal to T1 will be equal to 100 Newton. You're supposed to do it properly, but I do it straight the answer here. Okay, then using sigma fx equal to 0. If you do it properly, what you will get will be gx will be equal to 0. Then if we use sigma fy equal to 0, then you have to list out all the equation there. What you will get is gy will be equal to 100 Newton multiplied by sin 10 degrees, okay, plus 100 Newton multiplied by sin 10 degrees, both of those. So 2 times 100 Newton multiplied by sin 10 degree. So it's supposed to be around 34.728 Newton. That's our G1.
I'm sorry. Why do you get the GX suddenly? Why can you know it?
I calculate everything inside of my brain, Hasan. So
Oh,
this one, you have to do it properly. Okay, that's why I'm telling you. This one you're
okay,
supposed to do it properly. So you have to
Oh.
list out all the X direction. So you're supposed to have a T 100 Newton cos 10 degrees minus 100 Newton cos 10 degrees plus GX, right? If
Yes,
you have 100 Newton cos 10 degrees minus 100 Newton cos 10 degrees, it
cancels
will be
out.
cancelled out, right? Yeah. So GX will be equal to 0, right?
Oh, I thought there's some theory in there.
No.
Okay.
In order to make it faster, because if I list out all the equations there, it will
Oh
be
yeah,
too long.
I see.
The same
Okay.
as the same as sigma Fy equal to 0, what you will have is 100 Newton sin 10 degrees plus 100 Newton sin 10 degrees minus Gy equal to 0. So that's why Gy will be like this.
Hmm.
Right?
Okay.
And now, actually for F as well, you have to solve it. Okay, for F as well, you have to solve it. You will have a Fx and Fy there. Okay, for F, you have to solve it. But later, you will know why I don't solve for F. Okay, let me redraw the problem just now. Okay? So this is our problem just now. But I draw it only the whole system. Okay, sorry. I redraw the whole system, but all the external forces I will put it there. Yeah. Okay. Something like this. Okay. Then just now the X here. Then we have what's the name? The XY. This one is the UK. Then after that, our AY, just know what is the value of our AY? 117.364 going down. Okay. 117.364 Newton. And then EX is going to the right. 98. 98 point. I don't
98.48.
98.48. Okay, 98.48 Newton. What else that we have here? Oh, G at point G. I forgot this.
Hello students, welcome to my channel Engineers Academy.
Hello, Diva. Are you listening to the other lecture?
No, sir.
Okay. Then G there, what we will have is only GY 34.728. 34.728. 728 Newton. Then we're supposed to have Fx and Fy, right? There. As a reaction force, Fx, Fy as well. Okay. So actually, this is all the external forces that we have found up until now. Fx and Fy is not yet, Ax is not yet, Ex dy is not yet, right? And just now, the member that we need to find. Okay. The member that we need to find is CD, this one, PF, this one, and GF, this one. Okay. So this is the member that we need to find, this, and this. Okay, now I will ask you guys, what should we do? What should we do after this? Do we need to cut? What we should do in order to solve for those three members? Hello, answer me, please.
I'm sorry, sir. Can you repeat?
What we should do in order to solve for those three members?
I think we don't need to cut, just go through with tension.
Section method.
And
You want to go through using a join method like that?
I think so, but I don't know.
Join method, if you want to use join method, we have to solve for this particular join. Actually, yes, you can solve it for that. This particular join, then after that, this particular join, then after this particular join.
Never mind.
There are a lot, right? There are a lot of join that we need to solve.
Yeah,
so what should we do then? Risky. If we want to use section method, which part are we supposed to cut?
We cut it diagonally.
Diagonal? You mean how diagonal?
Can you show the question again? Which point we would like to find? CD.
A C D B F G F. A B C D G F. Okay. A B C G F. C D B F G F. Remember that I give a tick there. This one. This. Those three.
Sir, would it be possible to save to do the BF first? So we cut it like at first vertically between B and C.
B and C, G and F, right? Like this, you mean?
Yes, sir.
Okay. Yes, of course you can do that. But before doing so, right, Meryl, can you find out any zero force member here? Meryl?
F?
F?
No, sir.
No zero force member. Anyone here can find out the zero force member. Remember, when we can find a zero force member, it will be simplify our calculation.
CF, sir?
Yes, correct. CF is actually zero force member. If CF is zero force member, what's the effect of what's the value of BC and CD, Meryl? Will it be the same or not, Meryl?
The same, sir.
It's
will be exactly
will be zero, sir. This one, so it has no effect.
Yeah, CF is actually zero force member. Okay, CF is actually zero force member. Because CF is zero force member, the effect of zero force member there is if we take a look at join C, okay, then later we will find out that BC and CD will be exactly the same. So finding BC will be enough actually to find out CD. If you can take a look at that, actually one section is enough here. Okay, so actually, like what Meryl said just now, we can just cut it like this. Okay, now my free body diagram will become like this. Okay. I have external force like this, 98.48 Newton. I have 17.364 Newton. 34.728 Newton. And now, Meryl, if I want to assume all BC, BF, and GF are under tension, then the direction at joint B here is supposed to be going to the right or to the left for BC?
To the right, sir.
To the right, right. So this is FBC. And then for FBF, it's the same. I will assume it as tension. It's going to the top left or bottom right?
Bottom right.
Bottom right. This one. FBF. The last one, FGF. Right or left?
Right.
Tension as well. Huh?
Right, sir.
Right, correct. FGF. Okay. As usual for this one, actually I can draw the right free body diagram as well. But by just drawing the left free body diagram, it will be enough to solve the problem. So I will not touch the right free body diagram. The second free body diagram, I will not touch the second free body diagram. I will just use this particular free body diagram. Okay. Diva, can we solve this particular problem, Diva? Can we solve this particular free body diagram, Diva?
The one you just linkerin, sir.
Yes, yes. Can we solve it? We have three unknowns there.
Maybe I'm not quite sure, sir.
Yes, of course we can solve it because we have equation for each free body diagram. Huh? We have sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Three equation, three unknowns, can we solve it or not?
Yeah, I think.
Not I think. Yes, you can. Okay.
Okay.
Now let's try to solve it together. If I use the sigma moment at point B equal to 0, this is point B, this is point G, this is point A. Okay. If I use the angle just now, this one is 45 degrees, 10 degrees. A? That's not 45. Why they always use a difficult angle? Okay, 4 meters, 3.5 meters. So the length here is 3.5 meters. Okay, the length here is 4 meters. Sorry. Okay, 4 meters. That's correct. Okay, because of that, the angle of the FBF, we have to find it first, theta here. There is a theta there, right? We have to find it first because it's not 45 degrees. .5 divided by 4. So theta, tangent theta, it will be 3.5 divided by 4. Okay, shift tangent. Yeah. Shift tangent 3.5 divided by 4. Okay, it's supposed to be theta will be 186 degrees. That's the angle there. Theta, the angle there. Okay. Using sigma moment at point B, we will be able to find out for FGF. Okay. Let's try to calculate it together. Sigma moment at point B equal to 0. Sigma moment at point B, all the forces there will be there. So I will list out all the equation. Okay. So if clockwise moment is positive, what we will get is this one will be 0. Clockwise. Counterclockwise. Everything will be counterclockwise. Counterclockwise. Sorry. Counterclockwise moment will be 0. They will be positive. Then 98.48 multiplied by 3.5 plus 117.364 multiplied by 4 meter plus FGF multiplied by 3.5 equal to 0. So what we will get later will be FGF will be equal to minus 98.48 minus 117.364 multiplied by 4 divided by 3.5. Okay. Then we will have the results. It will be minus there. 117.364 multiplied by 4 divided by 3.5. 134 plus okay, so your results will be like this. 2.6 ton.
So it will be compression, is that?
Yes, Irfan. Yes, it will be compression. Newton. So minus 232.61. Minus it means that it will be 232.61 Newton compression. Like that. So we got the first force value there. Okay, FGF we got it. Now what left is by using the sigma Fx equal to 0 and sigma Fy equal to 0 to solve for the remaining forces. Okay, I will use sigma Fy first. Sigma Fy equal to 0. By using sigma Fy equal to 0, what will I get will be if going up is positive. Okay, what will I get will be 34.728 Newton minus 17.364 Newton. Okay, that's all. Then minus FPF. Okay, minus FPF multiplied by what's that? Sin theta. Sin theta equal to 0. Then our FPF will be 34.728 minus 117.364 divided by sin theta. So our FPF will be compression as well. There. 34.728 minus 117.364. 82.636 multiplied by sin 41.186. So this is your results, minus 54.416 Newton. Okay, or 54.416 Newton compression.
Sir, the moment is terhadap G ya, G ya? Or B?
Point B. Yeah.
Oh,
Why
okay.
I use point as the moment, as the center of moment, is because at point B there are two unknowns. So use sigma moment at the point where we have the most unknown. Because by doing so, you will be able to eliminate more unknowns. You get it, Hasan?
Oh, yes, sir. Oh, okay. I see.
Because by doing so, we will be able to get FGF directly. Right?
Yes, and then we can calculate the GB and find the FBF and the BC.
Yeah. This one is FBF. Okay. We have FBF. We have FBF there. Then using sigma fx, I will not be calculating it here. I will not calculate it here. But using sigma fx equal to 0, because FBF is known and FGF is known as well. Using sigma fx equal to 0, then you will be able to find sigma FBC. Right? Okay, you have to find it out by yourself. Okay, because it's just simple using the sigma fx equal to 0. Okay, any question about this? This is another example on this.
Sir, I want to ask why
Yep.
CF is equal to 0 because there is FX force.
CF equal to 0. Oh, CF equal to 0. Yes. There is Fx and Fy at point F. Yes, correct. But if you take a look at joint C, remember what I told you yesterday, William. So if based on one end, one particular member is already determined as zero force member, then it will be zero force member. So you have to check both ends.
Oh.
For at point F, yes, we cannot determine whether CF is zero force member or not. But at point C, we can determine that CF is zero force member based on our second type of zero force member yesterday. Right?
Oh, okay, sir.
Yeah. So because at point C, we determine that CF is zero force member, whatever happening at point F, it will not affect the zero force member. So it will still be zero force member. Okay, William?
Okay, sir. Thank you, sir.
Any other question? Before I explain about the next one. This one is about the last theory that you're supposed to know regarding the thrust. Any question? Meryl, do you get everything, Meryl?
Yes, sir.
Good. What else here? Irfan. Hello, sir. Do you get everything, Irfan? You seems like just now seems like you unmute yourself and I
Oh
can
no,
hear.
sir. It's by mistake, sir.
Oh yeah. But it seems like you are still sleepy.
Quite, sir.
Quite. Okay. You get it, Irfan.
I think I'll have to go through more practice, sir.
Yeah. Okay then. Don't worry about it. After this, I will give you several homeworks.
Okay, sir.
As usual, I will give you several homework after this. Okay. Fasa. Fasa Diara. Do you get everything, Fasa?
Yes, I understand.
Good, good. Jovan?
Yes, sir.
You get it?
Yes, I get it.
Good. How about you, Sakil? Hello, Sakil. Where is Sakil?
Yes, sir.
Okay. Do you get everything, Sakil?
Yes.
Okay. If you still don't understand in some part, it is better for you to go through the video again. Okay. Everything I will be uploaded by the latest is tonight. Okay.
Okay, sir.
Yep. Sunita, how about you? Do you get it? Hello, Sunita. Where are you? Don't sleep again, okay? Although it's very early in the morning, but don't sleep again. Nuki? Adila? Everything clear.
Currently, no questions, sir. But I don't know when, if there are tests, I can do it or not.
It is better for you to keep practicing, Nuki. Okay, you will know about that after when you keep practicing. Oh, after this, I will give all of you guys like 5 problems for your next homework, and try your best to solve it by yourself. Okay, by doing so, you will be you will by doing so you will know whether you truly understand about my explanation or not. If you yet to understand, then try to rewatch the video. Okay? Yes, Rizky.
I just want to make sure because earlier I don't really sure, but we only take one free body diagram, like you just circle the left one. It's because the right one have the will have same magnitude as the left one if we carry.
Yes, correct. Yes, correct. We don't have to solve both for this particular case. Okay?
Karena
sometimes
bentuknya sama gitu ya, Pak?
Nah, bukan bentuknya sama. Karena kita di kiri dan di kanan itu kan unknowns yang kita harus solve sama.
Oh, yeah, so I realized from your working in here, there's no like mention of FCD. Is it because you replace it with FBC? Because
Yeah. Just know because CF is zero force member, right? If we use point C, if we calculate everything at point C, if we use joint method at point C, what you will get using sigma fx equal to 0 at joint C is FBC will be equal to FCD. Yeah. So after you solve this, then you can solve FCD. Okay, sir?
Oh, okay, sir.
Okay, Rizky, continue.
Yes, but I still I know that the magnitude will be the same, but I don't really get the concept how.
So basically like this, Rizky. If just by using one side of free body diagram, just by using one free body diagram is enough to solve everything, then it's better for you. Because by solving only 3 equations, you can solve everything. Right, Rizky?
Yes, but
yeah. But sometimes, in some case, especially in a statically indeterminate case. Okay, like it or not, we have to use both. That's the thing that I will discuss after this.
Okay.
Okay.
Okay, Pak.
I'm still checking with the other lecture where the statically determinate. Actually, it's not statically indeterminate, but in bahasa we call it as trust tidak sederhana. Okay. So, but basically the number of equation is more than the number of unknowns is more than the number of equation. That's why I call it as statically indeterminate. Okay. This is another case about a pulley, and I think for this one I will give it as your homework later, part of your homework, because it's the way to solve it is quite the same as the previous problem that we discussed just now. Yep. So the next thing that we want to discuss is in bahasa we call it as trust tidak sederhana. I'm not so sure what is in English. Anyone knows what is tidak sederhana in English? Hello, Rizky. Oh, Azhar, can you translate it for me, Azhar?
Oh, which part, sir?
Trust tidak sederhana in English. What we supposed to call it?
Trust tidak sederhana.
Not traditional, Pak.
Non-ideal trust.
Yeah, actually, so basically, the trust that the trust system that we want to discuss is the number of equation that we have is less. Okay, the number of equation that we have are less than the number of unknowns that we have to solve. So that's why I call it as a statically indeterminate structure. Although maybe it's wrong terms like that, but the main thing here is the number of constraints or the number of external force or the number of, actually it's not the number of external force, but the number of unknowns. Okay, the number of unknowns okay is more than the number of equilibrium equation. I'm so sorry about my writing. Okay, I don't know why my writing is getting worse and worse because of this pandemic. Because I only write digitally like this. Okay, but I'm pretty sure that you can read it, right? Azhar, can you read it, Azhar?
Number of unknowns
is more than the number of equilibrium equation.
Okay, I can read it.
Yeah. Okay. Some even my wife told me that my writing is like in bahasa we call it a sandi rumput. You know about sandi rumput? Anyone here join pramuka or something like that? Rizky, do you know about sandi rumput, Rizky?
I've heard that, but yeah, I don't really.
Yeah, but it's something like that.
Yes.
So even worse than a doctor, my wife said. But anyway, yeah. Anyway, it's okay because I cannot solve. I cannot fix it. So if you have any problem in reading my writing, please let me know. Okay. So the point is that the number of unknowns is more than the number of equilibrium equation. Okay. The number of equilibrium equation. That's why we have to modify it in order for us to get more equilibrium equation. Okay. This is some of the example. Okay, please try to understand about this. So the frame here, not the frame. This one is a truss system. The truss system A, C, E, D, F, P are connected by two force member A, B, and C, D. But remember, A, B, and C, D is not connected in the middle there. Here, there is no connection there. There is no connection between A, B, and C, D there. The one that we're supposed to solve is the force which is happening at AB. Okay, the force which is happening at AB. Compute the force in AB.
Sir, I want to ask.
Yes, Azhar.
Is it nombok or intersection in the middle?
The middle, the one that I circled.
Yes.
Right? No, it's like a just pass through each other without touching each other, like this.
Oh.
Okay. So there is no connection there. Yeah, there is no connection there.
Okay. So different calculation like that, I mean, sir. The AB, CD.
Yeah, AB is one two force member, and CD is another two force member, and there is no connection between those two. Okay. So this is one of the simplest problem about the truss system, statically indeterminate truss system. Okay, so let's try to solve it together. Can anyone here give me any idea on how to solve it?
Maybe search for the angle first, sir.
Oh yes, of course. The first assumption is all the angles are found, because my main idea, my main discussion here, the things that I want to discuss the most here is not how you find the angle. How you find the angle is about trigonometry, is about geometric things. And if you know mathematics, if you master mathematics, you will be able to find it. But now, the things that I want to discuss is about how can we handle truss system, truss structure, where this kind of truss structure, how can we solve it? That's the thing. So we assume that all the angles are found. Okay?
Oh, I see.
Find the external force first, Pak.
Find the external force. Okay, let's try to find the external force. Then let's draw the free body diagram. Then is key correct? Right? The whole free body diagram.
Yes.
Okay, let's try. It's become interesting. Okay, this like this. Okay. Now it become like this, something like that.
Yes.
Okay. Then we have 10 kilonewton. What else do we have?
EX, EY, and
yeah.
FX, FY.
Yes, correct. At E there is a pin joint, and at F there is a pin joint as well. So EY, EX, EK, FX, FY. Okay, now I'm asking you, Rizky, how many unknowns do we have here?
We got EA, EC.
EA.
Okay.
How many unknowns do we have here? This one is unknowns, right?
Oh, yes. Four unknowns.
We have 4 unknowns. How many equations do we have for one free body diagram? Rizky.
Sorry, sir?
how many equations, equilibrium equation that we have in
Oh,
one free body diagram. This one is one free body diagram.
yang tadi ya, Pak.
Yes, of course. How many equations that we have? How many equilibrium equation that we have in one free body diagram?
3, Pak.
Okay, sigma fx equal to 0.
Sigma Fy to 0 and sigma moment to 0.
Can we solve 4 unknowns with only 3 equations?
I think so.
You think so? How come?
We can use the sigma moment, I think.
We can't. We cannot.
Maybe sections.
Okay. But before that, I need to split something out from this key. This key, we can only solve 4. Okay. If the number of equilibrium equation is less, or that if the number of equations is less than the unknowns, okay, for sure we will not be able to solve all the unknowns. This key. Okay, remember, right? If we want to solve for 3 unknowns, we have to have 3 equations.
Okay.
That's the basic concept. Okay. If we want to solve for 4 unknowns, we have to have 4 equations. Here we only have 3 equations, so it means that we only can solve for 3 unknowns. So we will not be able to solve it completely. Okay, Rizky?
Okay.
So it's unsolvable with only one free body diagram like this. Okay, that's one point that we get. Yeah. Okay, now Asar, just now what did you say? Just now what did you say just now?
Do we cut it to 2? Maybe.
Cut it into 2. Where?
Yes.
Where we supposed to cut?
I think the middle. Wait.
Middle is which means that we cut member AB and member C.
I'm sorry, sir.
That means we cut member AB and CD, right?
Yes, I think it's in the middle. I think the cut.
Okay, let's try. Let's try to do that cut. By doing that cutting, and remember in the middle, CD and AB are not connected. So if we cut it this way, then AB and CD, those two will become external poles, and those two has no connection to each other. Okay, now we can draw one free body diagram. The left one will become like this. Okay, we will still have EY and EX. Okay, and beside that we will have CD and AB. Okay, as usual, we always assume it, I always assume it as tension force. Yeah, so CD will be under tension and EB will be under tension. If CD is under tension, where's the direction of FCD in the left free body diagram?
It is right top.
Top right. Okay.
Yes.
Yeah. Right.
And AB is bottom right.
Bottom right. Okay. FCD. This one is F. A. Something like that, right?
Yes.
And then if we draw the right free body diagram, it will be like this. It will be like this. Okay, the dimension is slightly off, but still okay. Fy, Fx, we have 10 kilonewton. What else there? On the right free body diagram, what's that?
The
FC and FAB still tension, right?
Yes.
Okay. FCD, if it's tension, then where is the direction here?
Left bottom, sir.
Good. Yeah, correct. Bottom left like this. FC. Okay. FAB.
To the left top.
Top left. Okay.
Oh yeah, top left.
Something like this, right?
Yes.
How many unknowns in total that we have? Okay, then I will not ask you like that. Let's see one by one first. This is the first free body diagram, and this is the second free body diagram. If I take a look at the first free body diagram, how many unknowns do we have?
4.
4. How many equations do we have there to solve for the 4 unknowns?
The equation that you mean is the sigma fx, sigma fy, and sigma moment, right?
Yes. Yeah.
3. So we cannot, yes, sir.
Only
In
3.
that case.
Yeah. Sigma fx of okay. Sigma fx1. So for the first free body diagram, we have sigma fx1
equals to 0.
because this is 1 here is for the first free body diagram, right?
Yes.
Sigma fy1 and sigma moment 1 equal to 0. Okay, so this is for the first free body diagram. The list of equations that we can use for the first free body diagram. Okay, but unfortunately we have 4 unknowns, right? 1, 2, 3, 4.
Yes.
We cannot solve it, right?
Yes.
Now take a look at the second free body diagram. How many unknowns do we have?
We have 4.
4 as well. How many equations do we have?
3.
3 as well. Yeah. Sorry for this. Sigma fx2 equal to 0. Sigma fy2 equal to 0. And sigma moment 2 equal to 0. These 2 equations are 2 different equations, 2 different sets of equations, right? But still, if we only take a look at the second set of equation, it will not be able to solve for the second free body diagram because in the second free body diagram we have 4 unknowns, right?
Yes. Yes.
But in total, now let's take a look. In total, from the first and the second free body diagram, how many unknowns do we have?
8, sir.
Calculate
wait.
again.
Unknowns, right, yes, sir?
Unknowns, total unknowns.
4. If I think.
Not 4.
Because
1,
FCD.
2, 3, 4.
Sorry.
FCD and FAB, you need just to calculate it once. Right? It's just FAB in the left free body diagram and the right free body diagram are the
6,
same.
yes, sir.
FCD in the left, and so yes, we have 6 unknowns.
Oh, okay.
Now I'm asking you, in total, from the first and the second free body diagram, we have how many equations?
6.
How many equilibrium equations? 6 as well. In total, here we have 6 equilibrium equation. 6 unknowns, 6 equations. Can we solve it?
Yes, we can.
Yes, we can. This is the case where we have to use both free body diagram. We have to use all equations in both free body diagram. Rizky, do you get it, Rizky?
I get it, Pak.
Asyar, do you get it?
So basically, the unknowns we're trying to identify is just the penjabaran of the first 3 main unknowns, sir.
Sorry, I don't get what your question is.
So the unknowns you find in the part 1 and the part 2 is basically the penjabaran of the sigma fx equals 0, sir.
Sigma fx. No, yeah, actually, all the unknowns there is actually the whole unknowns that we have in the whole free body both free body diagram. So ex ey is there, fx fy is there, and because we divide it into 2 free body diagram, then we have fab and fcd. So in total we have 6 unknowns.
Oh, I see. Okay, sir. Now I understand.
And in total we have 6 equilibrium equations as well. 3 from the first free body diagram and 3 from the second free body diagram.
But how to use it, Pak?
Okay. Just using elimination and substitution, Rizky. Now it's become a mathematical problem. Did you get it, Rizky? Hello, Rizky?
I think I need to see it first.
You need to try it, okay? Because solving 6 equations, 6 unknowns with 6 equations, it's obviously way harder than solving 3 equations, 3 unknowns. 3 equations, 3 unknowns, you did it quite a lot of time, I believe. So it will not be a problem for you. But 6 unknowns, 6 equations, yes, you have to try it. You have to try it first. Okay.
Pak, ini the substitution elimination-nya itu yang first body diagram, one equation ya, yang three unknowns. Terus second body diagram, atau gimana itu substitution elimination-nya?
Substitusi eliminasinya ya dicampur-campur, cuman sebaiknya dibuat sedemikian rupa supaya substitusi eliminasinya itu mulai menghilangkan unknowns-nya satu persatu. Jadi kalau misalkan tidak dilakukan dengan benar, hasilnya nanti malah jadi persamanya tambah banyak atau malah jadi unknowns-nya tidak terselesaikan, Matthew.
Oh, pakai kan ada 3. Ini substitusi eliminasinya yang tiga apa sih namanya? 3 suku atau yang 2 suku gitu, Pak?
3 suku, 2 suku.
Apa ya namanya? 3 variable.
Ini 6 suku, 6 persamaan, Matthew.
Oh, jadi get creative aja.
Yep. Try to get creative. Okay. The things that I will suggest you to do if you have this kind of problem, for sure, you will not be having EX and EY in the second equation, and you will not be you will not have FX and FY in the first set of equations. So in here, there will be no Fx and Fy. Here, there will be no Ex and Ey. So what you can do, okay, from the first free body diagram, what you can do is to try to eliminate Ex and Ey. And from the second free body diagram, what you can do is to try to eliminate Fx and Fy. After you able to do so, the n equation that you have here is just will be one equation which has only FAB and FCD. And from the first equation, from the first set of equation, you will have one equation as well, which has FAB and FCD. Then from those two, you can solve for FAB and FCD. That's the strategy that you're supposed to use. Okay, first step, solve because FAB and FCD, it belongs to both sets of equation. But EX, EY only belongs to the first set of equation. Fx, Fy only belongs to the second set of equations. So from the first set of equation, you can eliminate EX and EY. From the second set of equation, you can eliminate Fx and Fy. Okay, that's the purpose. Then from both, from the first and the second set of equation, at the end, you will have from each set of equation, you will have one final equation which consists of only FAB and FCD. From the first, we have one equation that consists of FAB and FCD. From the second set of equation, at the end, we will finalize it with one equation which consists of FAB and FCD. Then after that, you can substitute and eliminate to find FAB and FCD. Do you get it, Matthew?
Yeah. How about ini? Kalau di left down nggak bisa ya, sir?
No. It's impossible. This is
never mind.
type of problem here.
EX, kalau misalnya EX tahu bisa nggak sih, Pak? Misalnya EX tahu nih value-nya.
You will not be able to find EX value
Hmm.
just by using the left equation, the first set of equation. No, you will not be able to do that.
Oh, okay.
So solving EX and EY and FX, FY, it will be at the end after you solve for AB, FAB, and FCD. The first thing that you can do is to eliminate EX, EY in the first set of equation using the first set of equation. Then final equation that you come out with from the first set of equation, it will be only consist of FAB and FCD. That's the strategy, the only strategy that you can use. Okay, the same for the second one. It's quite complicated, yes. Okay, Matthew?
Okay, sir.
Sir, I want to ask. So basically, we just have to find we have to like separate first, right? The first and two, and then get the equation from one, get the equation from two, and then substitute, eliminate like that. Yes.
Yep. But the equation, the final equation that you get from the first set of equation is only consists of FAB and FCD. The same as the final equation that you get from the second set of equation, it will be just only consist of FAB and FCD, because the first step is supposed to eliminate EX, EY in the first set of equation, and FX, FY, eliminate FX, FY in the second set of equation.
So we need to eliminate forces that are unnecessary to find, yes, sir. Like the EX and EY.
Actually, it's not unnecessary to find, but EX and EY only belongs to the first set of equation. So we have to eliminate that in order to solve for the system. Because in order for you to solve it, right, you have to solve for in order to solve for FAB and FCD, you have to use both set of equation. And you will not be able to solve for both set of equation at the same time. So what you can do is, using the first set, second set, eliminate the one that has no connection with each other. Then after you find out the equation, one equation from the first set equation, from the first set, and one equation from the second set, it only consists of FAB and FCD. Then you can solve for it. Two equation, two unknowns. Yes, that's the step. Actually, it will be hard if you don't try it by yourself. Okay, Azad, try it first. The things that you have to do after this is to try to solve for this problem. Okay?
Okay, sir.
This is another thing that is quite similar to the previous one. Okay? For this one, we can cut it in the middle as well. Okay? We can cut it in the middle. We can cut it in the middle, and we can what we will have later will be like this. It will be quite similar with the previous one. Okay, this is the first free body diagram, and this is the second free body diagram. Okay, but because there is a 5,000 pound there, then you have to divide the 5,000 pound there. Okay, but at the end, you have to solve for 6 equation and 6 unknown as well here. Okay. This kind of problem is quite difficult to solve. Yes, but try your best to understand. Okay, although don't make it as your main focus, but because sometimes it will come up in the exam, but sometimes it will not come up in the exam. But you have to know about this particular problem. Okay. Discard file. Later, I will give you several homework. Maybe it will not be the same as this one, because some of this we already discussed it in our class. Like this, we have discussed it. This one as well, we have discussed it. So I will choose several other problems. Okay. This one is quite difficult because it's a part of the statically indeterminate thrust. Okay, so I will put it at number 5 because it's the hardest one. This one is the previous exam problem. So the previous exam problem will have the difficulties like number 4, like this particular problem and this particular problem, and it will be there in your homework. Okay, it will be there in your homework. So try your best to solve this particular homework by yourself, because in this particular homework, I give several examples of the previous exam problem. Okay, do you get it, guys? Okay, any more questions before I close the class? Before I conclude the class? Yes, Matthew.
Pak, tadi yang dibagi jadi 2 itu, yang jadi 250, 2,500. Kalau
Yes,
bagian kiri sama bagian kanan yang nggak sama persis juga kebagi 2 nggak?
It will be exact. It will be just okay. Wait a minute. Let me check. Start now. Then file. You mean this one? Yeah. What's your question again?
If di section cutnya di C kan.
So basically for this one, we don't use section, but at joint C, we release joint C. So it becomes 2 separate structure, right? Okay.
So if bagian kiri, let's say beda pokoknya beda gitu, still kebagi 2 force-nya.
Actually, you can do whatever you like with the external force. So the external force, you can just put 5,000 lb on the left only and nothing on the right. But later, the Cx and Cy there, Cx and Cy, it will why keep doing it this way? Cx and Cy, it will adjust based on that. So basically, in total later, it will be more or less the same. So you don't have to divide it 2,000 to 2,500, 2,500 later. You can divide it 5,000 and nothing on the right.
So intinya Cx kiri plus Cx kanan must be 5,000.
No. Later, Cy plus 5,000. Okay, on the left and on the right, it will be more or less the same. You get it? Because you have to try it. Matthew. Okay. We
More
have
or
to
less
try
the
first.
same.
Yep. So
Tapi
basically,
kalau force-nya nggak dibagi rata, harusnya nggak ada same dong, sir.
No.
No.
Nope. Wait, let me explain to you once again. Okay, this one. Okay, just now I told you, right? We can divide this into two free body diagram like this. Okay. And then this one as well. Like this. This is the external forces. And then AY, AX, EX, EY, and then CXEY, right? This is point C, this is point C. And actually I can do it this way. If I want 5,000 LBF, then CY, then CX. This one is CX, this one is CY. Remember, CXCY, why the direction is like that is because it must be action and reaction. Okay, Matthew. Okay, that's why if on the left part I put CX to the right part I have to put CX to the left. The same as CY. CY, if I put the left part going up, then on the right part it's supposed to be going down like that. But like this, the total of this and this, okay, it will give exactly the same effect to the left or to the right. Hello, Matthew?
Sorry, sir, I disconnected.
Yeah. So
intinya
I
CY.
can put it this. I can draw it like this, Matthew. And it will be just exactly the same as this one. Later, the effect will be exactly the same as this one. It will be exactly the same as this one. CXCY. Okay. It will be exactly the same as this one. The effect, okay, I'm talking about the effect. Okay, the effect will be exactly the same as that one. Why will be exactly the same? Later, the one that will be different there is the value of CY. Okay, the value of CY here in this particular set of free body diagram, and the first one, the first way and the second way, the value of CY there will be different. But the effect, the results of the rest, AX, EY, AX, EY, will be exactly the same using the first or the second one. You can find. Matthew. Do you get it, Matthew?
Yes, sir, will do. Thank you. Thank you, sir.
So later, the one that will be adjusting the value, everything is, it will be the CY. Okay, CY here and CY here, the value will be different. Okay, I think it's already 9 o'clock, and I have another class after this. I think that's all for today. Okay, if you still have any question, you can ask me next week. Okay, but unfortunately for us, Thursday is holiday, right? Yeah, so
Yes,
we will not. Yeah, so we will not have any class on Thursday, but I believe I will need to give you guys additional class the week after, because if not, because the week after it will be exam. We will have a 2 weeks from now. It will be exam. If I'm not mistaken, the exam will be 2 weeks from now. So before the exam, yeah, yes. Before the exam, I will need to give you guys additional class. Okay, just in
Okay,
order
Pak.
to make sure that you completely understand about everything that will be there in the exam. Okay then.
Okay, Pak.
I think thank you very much for listening. That's all for today. Okay, see you guys next week, and don't forget that to check the MS Team by tonight. I will post the homework there. Okay, see you guys.
Okay. Thank you very much, Pak.
Sir,
Goodbye.
thank you, sir.
Thank you, sir.
Thank you.